Hey guys, welcome back to TechDin. Today we'll see how we can develop API by integrating an external API in Golang. So in the last video, we saw how we can build a static API, but in this video, let's see how we can integrate an external API, customize the response, and serve it to the user. So let's get started. So I have created a blank project in my editor. So I've called it external API, and there's a plain Go mod. So I'm using Go 1.16, and the module is external API again. So let's start from scratch. So I'm gonna use Gorilla Mux API library for my routing. So let's add that. So I'm gonna just run this command in my terminal. So I'm just gonna say go get -github.com Gorilla Mux. That's how you install libraries, and my Go mod will be updated with that. Yes. So let me create a main file to start with, and I want to name the package as main. Okay, main function. Okay, so not hello world, external API. Tutorials. So let's run that. Should easily run. Yeah, it's running. Oh, let's create a route file first to start with. Routes. I'm gonna create a function routes, or let's say new router. And I'm gonna call router is equal to and it returns max.router and router. So in the main function, I will create in the main function, I will use the function that I just wrote called new router, and I'm gonna do HTTP. I'm gonna store the port number in a variable. So 1000, let's say 1000. And start the HTTP server using this command, say port, router. And if error is not equal to nil, then okay, just do log.fatal error. So this is the basic main function which starts the server at port 8000, and I have a basic router as well. So yeah, so let's create a handler for this. So today the external API that I'm talking about is a weather API. You can actually get a free API key by signing up in weatherapi.com, weather-api.com. So I'm gonna call my handler as weather handler. And I'm gonna go. So I'm gonna create a type weather handler. So I won't add anything if now I'm gonna add a receiver function for this handler. So all handlers have this specific signature for the go to work, for the handler, for the router to work. So we will have first parameter as response writer. Basically response writer is http.response writer, and request is a pointer to http request. So yeah, so see, as soon as I write that, the IDE recognizes that this function is of type handler function, handler. So currently I'm not going to do anything right now. First, and then for the router, I'm gonna create a first route, router.handle weather slash, I think it's weather and country, and so I'm gonna send a pointer of that. So now all the requests that is coming to this API, weather slash the country name, will be handled by this HTTP method. Yeah, so let me explain the API URL here. So this will be the API path, and API path has static part, which is nothing but slash weather, and slash, this is the dynamic part. This is where you can pass any country that you like, and this could be retrieved as a URL parameter. Let's see how we can do that. It should be like this. It should be like this. Sorry about that. It should be like this country. So you can retrieve the path parameters using max.wars of our request, passing the request, and we can say you have to println. So let's see if this works. So let me start the server. Yeah, my server. Yeah, so let's see. Let's try to access that API in the browser. And yeah, here it is. And let's say I'm gonna call weather slash simple. Yes, it seems to work, and I can see the log. The country passed is Singapore. Yeah, so let's go ahead. So my handler is this. So I will create a service file, which will be responsible to make the external API call. So I'm going to call weather service. I'm going to keep the empty struct and write the receiver function. I'm going to call this get weather by country, and I'm going to pass the country as a string. Currently I still don't know what would be the response type yet, and I would want to make this weather service as a dependency in the handler. So that's where, so let's say service weather service. It would be a explicit dependency, and I would write simple constructor for this handler called new weather handler, which takes in a service of type weather service, returns weather handler. Yeah, so yeah, so here I would say in the main, in the router, rather than doing this. Okay, I'll return a pointer here for convenience. So we'll go to we'll get to see how we can initialize the weather service. I'm going to just keep it like this for now because it doesn't have any dependency. Okay, coming to this one. So for weather service, I would require to initialize to call a weather service. I would require a host of type string, and yeah, I think host is required, and I want a HTTP client. Will it be of type HTTP client? So now I would want to create a constructor for this weather service because it has more parameters. I'm going to use this in my router. So currently I know that from the documentation of the weather API, so weather API host is equal to, so this is my client. So HTTP client, let's initialize a basic client. Or I can say there's a default client. So I've not configured anything. So, but in production environment, you need to configure HTTP client with the right parameters like timeouts or the other behaviors. So you just cannot go with the default client in a production environment. So, and ideally we should be reading these information from some kind of config file or a config provider. But for now, for this tutorial, I'll keep it simple. Yeah. Let's go back to implementing the service. Okay, the full URL is going to look like the host. First will be the host, and the your key will be the API key. So I'll be adding the API key here as well. And q is equal to, we can pass the country here. So I'm gonna add the API key as well. It will be format, and this will be the whole URL for the API. This API takes a lot of other parameters, but for this tutorial I'll keep it very simple. Yeah, and actually after the host there is something called as current.json. So that gives you this is the API which gives us the current weather details. So in the response body, let me show you how the response would look like. Yeah, this is how the response would look like. Let's say we are just interested in this part of the response. In any microservice, when you want to consume a response from a different API, you normally serialize that to a particular class, a particular object. In Golang, we serialize this JSON data to a struct. So let's see how we can serialize this into a struct. First, I'm going to use an online tool for now to convert this JSON to a Golang struct. I'm going to create a model here. So I'm going to call this weather response. So this is the response. I'm going to call this weather response. So yeah, this is the name of the fields, and this particular tag tells how to serialize, like what's the JSON field will look like, and like where the JSON serializer should look, which field it should look to serialize this particular field in the struct. So let's say I don't want to do this. Let's say I'm not interested in this particular response. I'm gonna just delete that, and let's say I'm not interested in this. I'm interested in temp C, that is Celsius, temperature in Celsius, temperature in Fahrenheit, is day. Let's say I'm interested in all of this data. So I already have a search.client, so I'm going to create a HTTP request here. Let's say first I would do the http.new request. This will be get, and your URL command L. Yeah, there's no body, and if error is not equal to nil, return. Yeah, now that I know what would be the response, I can say it's weather response comma error. In case I encounter an error, I need to return it. So I'm gonna make this a pointer so that it can return nil comma error. And now I can do response comma error is equal to, I already have its client dot do request, and if error is not equal to nil. Again, do the same thing. So once the response is valid, I want to check if response status is not equal to http status. Okay. Oh yeah, oh sorry, this is status code, and I'm gonna call errors.new whether API responded with non-okay response. Non-okay status code. So only then I want to read all the data. IoT dot read all dot response dot body. And I want to do, even if there is an error or not, I want to do, so we need to do this because to avoid memory leak. Because if there is any error during this and the response body is normally left open, and this causes a lot of memory leak. Now what's the error here? Or not, it's not read all, not read it. And now I'm gonna create a variable of type weather response so that I can deserialize JSON to bytes to the variable of type weather response. So how would I do that? Is JSON dot unmarshal, pass in the bytes data first and the pointer to the variable, and if there is any error, again return the error, else return the weather response, manual. And so this one should be like this. Yeah, I think now we're set, and now we should use this inside our weather handler. So the country passed is this one, and response comma error is equal to handler.service dot get weather by country is equal to passing the store this variable in variable called country. Use this in the log message here and send the same. And so if error is not equal to nil, then we should send HTTP 500. Right, maybe like an error message of else got the response here, and I will I'm gonna do the marshalling. You need to do convert back to the bytes, the response. When you're serializing again. So again, if there is a null error, just do again. Sorry, this one is bytes. And so if there is no error, then response write the bytes. So yeah, so let's see if this works. Oh, there is something. Oh yeah, I need to pass in the API key. I'm not gonna show it, but I'm gonna send that. Yeah, the server has started. Let's see if this, yes, it works. Yeah, this particular browser doesn't have the JSON formatter, but yeah. So now we see that the response that we were interested is correctly serialized and served to the user. Yeah, so we can even go and modify this however we want, like changing the fields, transforming the response to a completely new response and save it to the user according to the needs. Yeah, so this is all, guys. Let's see a more complex example in the next video. Thank you for watching. See ya.